Today's video explains how calculations can be done for bases. Just as strong acids will give more hydronium ions, strong bases will give more hydroxide ions. Metal hydroxides will dissociate completely in water and are considered to be strong bases. Any bases that do not dissociate completely are considered to be weak bases. Bases are listed on the acid-base table from weakest to strongest. The Ka value is listed for every acid, but no value is given to show how much the conjugate bases will react with water. For comparison, here are two base reactions with water. Sodium hydroxide is a metal hydroxide, and so it reacts completely with water. The other base is a weak base, and so it does not completely react with water. When we are dealing with weak bases, we will need to use a base ionization constant. The calculations used are very similar to those used with Ka. See here how the base ionization constant can be determined by using the concentrations of the products and reactants. In this example, you are given a concentration and a pH for a base and are asked to determine the base ionization constant. The concentration given is not a molar concentration, so the molar mass needs to be used to convert the value to the proper units. This value is going to give you the initial value for the concentration in your ICE table. The concentration of hydroxide ions can also be determined. In this question, you are given the pH, so subtract this value from 14 to get the pOH. Then you can solve for the concentration of hydroxide ions at equilibrium. Enter all of your known values on the ICE table and fill in the rest of the values as you can. Now that you have determined the values for each entity at equilibrium, you should be able to solve for Kb. The other type of calculation you will need to be able to perform involves determining the pOH or pH of an acid or base. Because the acid-base table does not provide values for Kb, we need a formula to allow us to convert Ka values to Kb values. This is the formula here. The value of Ka multiplied by Kb will give you Kw. In this example, you are asked to find the concentration of hydroxide ions and the pH of a quinine solution. The value for Kb is given. Begin with your ICE table. The concentration of quinine is the initial value. Check if you can use the assumption. The concentration divided by the Kb value is greater than 1,000. So we can assume that the ionization amount for the reactant is negligible. This means that we can solve for X more easily. Algebra is used to solve for X here, which corresponds to the concentration of hydroxide ions. The negative log of the hydroxide ion concentration will give the pOH. When we subtract the pOH from 14, we will get the pH. Please complete the December 17th quiz.